Why did I build something like this? Well, I am Swiss, and I feel like every Swiss person has to do something with chocolate and build a watch at some point in their life. I'd already made something out of chocolate, so I felt like a clock was the logical next step. So for the longest time now, I really wanted to make a clock, a big mechanical clock. But I don't want it to tell time with different hands in different positions. I want 4 numbers next to each other that tell time just like a digital display would. Sounds a bit weird, I know, but I promise it will make perfect sense in just a minute. Now, I've spent over a week now designing this whole thing with all the gears, all the different types of drive mechanisms, gear reductions, everything. And then after very minimal testing, and by minimal, I mean I made these 3 gears, I just decided to just cut all the parts. So I've already cut all the parts on the CNC machine. So I have this big box full of different gears and different sizes and different shapes. There's about 30 different ones in here. I've also got a bunch of really big frames. These parts is what's gonna hold everything together. I've cut really big gears, and the pieces that are gonna tell time are these rings, which will be stacked next to each other and able to rotate individually. And that's how I'm planning to tell time. So this would now be 1948. To be completely honest with you, I think there's a better chance that you're now watching a video of me failing to build a clock than it is me succeeding to build a clock the first try. But regardless, let's try and figure this out. Alright, so as you can see, there's a ton of different gears here. And most of these, there's only one of. But they all have to stack together in different assemblies, and they all have a really specific way in how they're meant to go together. That is going to be the first step, turning all these individual gears into a bunch of different gear assemblies that we can then use to hopefully build a clock. Oh, by the way, all these parts are cut out of yellow and black Velcro mat. Velcro mat is just basically MDF with pigment all the way through, and it's also a little bit harder, which I think makes it a pretty good fit to make gears, but I don't know. Alright, now bear with me as I'm going to try and explain how all these parts are going to be able to tell time. The face of the watch, or the display if you want to call it that, is made up of 4 rings that all interlock into each other. Now all these rings will be able to rotate independently of each other. There's 4 of them, and in all 4 of them I've routed in a bunch of numbers. And as you can see, the different discs have different amounts of numbers and different types of numbers, which all is to display the time that a digital display would. And now this is the cool part. As these different discs rotate, these 4 numbers will make up the time. So right now, the time is 9:35. In a minute, the outer ring will rotate. Now it's 9:36. And so on. And naturally, to get all this to work, we need a bunch of different gears and drive mechanisms to get these discs to spin at different times and at different speeds. But the thing that will drive all of this is a little stepper motor. And now that is also the one shortcut I've sort of taken with this project, because it was plenty complicated enough already. Instead of using a spring or some other type of mechanism with stored energy to drive the whole thing, like an old clock with a pendulum or a wristwatch, this thing is going to be driven by a stepper. Now this stepper is going to rotate once every minute. And when it does, it's going to drive this belt, which will then hook onto this 3D printed drive gear and start rotating one of the gears that I've cut. And through that motion, everything else will be controlled with just this one gear. And now this tiny gear is going to drive this really big gear and make this big circle rotate. Now this is the outermost ring that is going to tell the time. And you can see there's numbers from 1 to 9. So far so good, right? Pretty simple. Well, let me tell you, this is about where it stops being simple. Because for the next ring, the complication here is that I only want this to move over one section every time this big ring rotates one full revolution. And to do that, I've got a bunch of really cool gears and mechanisms. One of them looks like this, but to show you how that's gonna work, we're gonna have to assemble all the parts into the frames. Now I've made these 2 big things. These are made up of a bunch of black Velcro mat pieces, and these are hopefully what is gonna hold all these gears in place. The funny thing is that this kind of looks like just a really scaled up wristwatch, and I just really hope it works like one too. Now this big outer ring will spin on a bunch of bearings that are attached on these bolts with a bunch of spacers onto the frame, and this thing and now with that initial drive gear that is going to be driven with the motor installed, we got our first 2 gears. Now what comes next is going to be a series of gears, all leading to the next ring in here, clicking over one increment, one number, for every time this big ring does a full revolution. And the thing that has sort of been like the main challenge of this whole project is that I don't want these rings to slowly turn just like an hour or minute hand on a watch would. I could do that, I think it would be a whole lot easier, but I don't think it would look any good. Because most of the time it would be super hard to tell what time it is if this thing is sort of halfway in between two numbers. So the first mechanism that is going to allow this thing to go click instead of slow is what's kind of called a Geneva Drive. This consists of two parts. This thing that has 6 prongs and this thing that has a little pin with a bearing. To test this, I've got 2 bolts with the right distance in between. Now if I've done it right, and if I haven't, I really don't know what to do for the rest of this project. This thing should spin a 1/6 of a rotation every time this does one revolution. Why isn't it spinning? Not even close to lined up. I've definitely not done this right. Be right back. Just experiencing some minor, technical difficulties. All right, after a short break, we're back. I've remade a bunch of parts. Turns out I got some of the geometry wrong, I cut some of the parts wrong, and I glued them together wrong. Fixed all that. I haven't totally glued everything together yet because I figured this way is a good way of showing how this works. So just like before, this pin is meant to drive this gear. And most of the time, everything here is locked, this can't rotate, and this can spin freely. But when that pin goes there, so every full rotation, that thing spins 1/6 of a rotation. And as you can see, this whole thing spins really smoothly. That is because I've used bearings wherever I can. There's bearings on the inside here, there's bearings on the outside of this thing, there's also small bearings that act as that little pin. Because there's gonna be so much stuff going on in this machine and so much resistance from all the gears rubbing that I really wanna try and minimize that as much as possible. And now with a bunch of gears to connect this big outer ring all the way through to this one, this is the last piece. Hopefully this will still work. And now when I rotate this, at some point, that thing should rotate once. Now we want to connect that to this second ring. But first, a quick ad from today's sponsor, 3D.ru. Do you have a 3D printing related idea, but not enough experience, expertise, or money to put that into action? Well, sign up to a 3D.ru event, where you can win up to $1 million to make your idea reality. This competition is hosted by 3D.ru, the largest additive manufacturing company in the CIS region. Now, it doesn't need to be an idea for a new 3D printer. It can be materials, software, consumables, or whatever you can come up with. Any idea that can help advance the industry does deserve attention. And all you need to do to participate is create a short presentation of your idea, regardless whether it's just a concept that will require a lot of testing or a fully developed idea that just lacks funding. Experienced professionals who work in additive manufacturing will review your pitch, give you feedback, and potentially offer you partnership and funding to create your idea into reality. To learn more and to submit your idea, go to event.3d.ru. Now this big outer ring goes back on. Now the numbers are definitely not in the right place, but if I spin this at some point, I would say it's going pretty well. Up until now, this thing is able to count to 60. Unfortunately, that sort of means that we're done with the easy bit. Because somewhere along the way, we decided that it's a good idea to tell time by first counting to 60 and then counting to 24. So the natural thing to think now is that the next digit just needs to do the same thing as the outside here, go from 0 to 9, which is true, but it has to do it in sort of a weird way. And that's what this disc is for. So since the clock goes to 24 and not an even number like 20 or 30, this watch face now has to go from 0 all the way through 9 and back to 0. That's now 10 o'clock. Do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It's 20 o'clock. If all this made sense, we would start in 0 again and go all the way through 10. It doesn't, so we go 0, 1, 2, 3, 0. So there's actually 24 spots on this face to be able to make all this work. So the next gear reduction is naturally gonna have a really small step every time this thing rotates a full direction. Now we're gonna do that, obviously with a bunch of gears, and because otherwise these parts would just be super hidden away inside of the clock, I mounted them temporarily to this frame so you can see what's going on. So this inner ring will, through a bunch of gears, drive this gear, which drives this big gear in the back here, that drives this big disc. And for the most part, that disc does nothing. But as it gets to the small gear, it goes 1, 2, and does a full more revolution. 1, 2, full revolution. Isn't that cool? This is actually the same mechanism as those mechanical counters, thanks to Matthias Wandel for making a great video about this. It's able to do that because this small gear has a combination of 4 and 8 pins that lock it in place to this big disc, which has a big cutout that allows a tooth to pass through and advance with 2 gears. That really small gear will then drive this big gear, which will be attached to this base. And this sandwich of different types of gears will be mounted on the inside here, held in place with these really nice, really big bearings. All right, now this is the mechanism installed proper way around on this frame. When this thing now goes from 60 back to 0, that thing should move just a little bit. Huh? All right, I think I got it to work. Don't worry about the exact position of this thing. The important part is that this rotates a little bit when this goes to 0. Cool! We're on to the home stretch. This is the mechanism that will drive the centermost disc. But as luck will have it, that is also by far the most complicated one. At least it took me the longest to figure out. Since the disc we just installed goes through a pattern of 0 to 9, 0 to 9, and then 0 to 3, this disc in the middle will have to rotate at different times, every time it gets back to 0. So the way I'm gonna do that is with this thing. Now this big wheel looks very similar to the one we just installed. It has all but 2 of the teeth cut out so that once every revolution, it will drive that little gear by 2 teeth. Bum, bum. Now you might notice that this big gear has 3 of those. And those correspond to 0 through 9, 0 through 9, and 0 through 3. So that it goes click, nothing happens, click, same distance, click, and then short, click. I think that should work. So all that's left to do is connect this gear to that center wheel. I'm gonna do that with this disc. And here's also the reason why I use these really big bearings, because I've installed some smaller bearings on the inside of those. I've also turned this piece of round stock that I'm gonna use as a center shaft for it that will go through these bearings. Now that bearing has another bearing inside of the bearing that has a bearing inside of it. So this thing will go on there. And then once we put that big frame back on, this gear will connect these two, making all that spin. I think all the bits and pieces are on. The next step is to finally install these things. And as you can see, they've got no little upgrade. Into those pockets, I whacked in some 3D printed white letters. I think that looks real nice. Now, this thing can go back on here. All right, last bit. I hope I do this right. I'll glue it onto the shaft so I know it's in the right position. I'll be able to remove it from the other side afterwards anyways. So, guess what time it is? 22:41. Now, admittedly, yes, it's a little fast. I've just set the motor to spin 1 minute every couple of seconds to see how it actually looks. I also just got some super basic code that runs on a stepper motor and an Arduino. Thank you so much to Anders who helped me sort out all that super last minute. I'll leave a link to his YouTube channel down below. Now, there are a few things that I want to talk about here. First off, you see that the numbers don't quite line up. And I had actually made one of these that is sort of meant to go over here and show what time it is. First off, I'm not sure I love the look of this thing, but secondly, obviously these things don't line up well enough for this to like actually really look that good. Okay, let's see. Full hour. That worked. Also, just look at this contraption. There's so many gears, so many different gear mechanisms in here. I've reset it, so the next thing it will do now is do the full 1 hour. Why did I build something like this? Well, I am Swiss, and I feel like every Swiss person has to do something with chocolate and build a watch at some point in their life. I'd already made something out of chocolate. Watch that video right here. So I felt like a clock was the logical next step. All right, so before I address the elephant in the room, that being that center disc that you haven't seen moving yet, I just want to say this was so much fun to build. I learned a ton about gears, but their different gear mechanisms. I've also learned that I totally get why this is an actual profession, and I'm not qualified at all to try and build this in a week. But I still had a ton of fun. So let's talk about that center disc. All right, I've advanced the clock so that it's 9 minutes until the whole thing, all the letters should rotate all at the same time. But there is one design flaw with this whole thing, which, looking at it now, makes total sense. You can see that the distance between these numbers is really big. So I'm asking this entire gear mechanism at the very end to produce a really large motion. In fact, I'm asking the center one to make the most motion out of all of these. The one that's easiest to drive is only doing 1/10 of the circle. The one in the center is meant to do 1/6 of one. The mechanical advantage is just too great, and I don't think it will be able to rotate it. Ah, so close. Hold on, we'll do it again. If we give it a little bit of help. I mean, it sort of does it. The problem now that in that process, the stepper motor has skipped a bunch of steps and the clock is never going to show the right time anymore. But seeing that it was this close the first try really gives me confidence that if I was to do this again, I could just add the double amount of numbers in here, have it move half the distance, tighten up all the tolerances a little bit, and maybe have a working clock at the end. So guys, thank you so much for watching. This was a ton of fun to build. Now obviously there's not going to be any plans for you guys to build this thing. If you want to build any of my other projects though, you can go and check out my website, which is alch.shop. Otherwise, hit the like button if you enjoyed the video. Make sure to subscribe and ring that bell so you get notified every time I upload something new. I mean, it is really satisfying to watch. Alright, see you guys in the next one. Bye bye.